welcome to our deep dive, into the world of VR, AR, MR, and even the metaverse.
Wow.
We've got
Pick the topic today.
we've got a really fascinating stack of research and articles, all from Professor Yi-Kun Lee
Okay.
at Hong Kong University of Science and Technology.
Huh.
So we're
Yeah.
going to be kind of diving deep into this.
Excellent.
One of the things that I'm really excited about that we're going to uncover are the differences between immersion and presence.
Yes.
These key concepts that shape, your experience when you're in these virtual spaces.
Right.
And we'll even talk about the tech behind haptic feedback.
Oh, very cool.
That buzzy feeling that your phone makes.
Uh-huh.
But it gets way more interesting when we start talking about VR and AR.
Yeah, haptics are incredibly important for making those experiences believable.
Right.
It's one thing to see a virtual world, but to feel it.
To feel it, yeah.
That takes it to a whole other level.
Exactly. And to help us navigate all of this, we have expert speaker here who is deeply familiar with all of these technologies
I'll do my best.
and is going to help us connect the dots and understand why all this matters.
So,
Maybe we can just jump right in by defining our landscape a little bit.
sure.
When we talk VR, AR, MR,
Yeah.
virtual reality, augmented reality,
Yep.
mixed reality. Professor Lee's research lays out some interesting examples
Okay.
that really help us illustrate each concept.
All right.
So,
Let's hear it.
when you think VR, what do you think of?
When I think VR, I think of like Oculus Rift. Total immersion. You put the headset on and you are transported to a completely different environment.
Completely different.
It could be anything.
Yeah.
A fantastical landscape, a historical setting, even another planet.
Yeah. It just shuts out the real world and
Shuts it out.
you're someplace else.
You're in a virtual one. That's
Huh.
the idea.
That makes a lot of sense.
Yeah.
And then you have AR,
Yes.
which is more about enhancing
right.
our existing reality,
Thanks,
right?
right.
It's not necessarily taking us away from it.
You're still there.
Yeah.
Think of Google Maps AR functionality.
Oh, yeah.
You're still seeing the real world through your phone's camera,
Uh-huh.
but the app overlays digital information on top of it. Directions, points of interest, that sort of thing.
So it's augmenting what's already there.
Exactly. It's adding a digital layer.
Very cool.
Yeah.
Okay, so we've got VR immerses,
Yes.
AR overlays.
Overlays.
What about MR?
MR, the mysterious MR.
Where does that fit in?
Mixed reality that one aims to kind of blend the real and virtual even more seamlessly.
More seamlessly than AR.
Yeah.
Yep.
And the key here is interaction.
Okay.
So virtual objects aren't just superimposed on the real world. They can
Ooh.
actually interact with it.
Oh, wow.
Microsoft HoloLens is a great example of this.
Okay.
So imagine being able to design a product and then see a 3D model of it projected into your workspace.
Okay, so you could walk around it.
Yeah, you can walk around it, you can manipulate it, you can even see how it would fit with other physical objects.
Wow, that's amazing.
Yeah.
So it seems like there's been a huge surge in interest in development in all three of these areas.
Absolutely.
Professor Lee actually calls it a Cambrian explosion
A Cambrian explosion. I like that.
in VR, AR, MR tech,
Uh-huh.
and he mentions companies like Google, Oculus, Magic Leap.
Big players.
So what sparked this sudden growth?
Well, a few factors came together around 2014, 2015.
Okay.
There were significant technological advancements, of course.
Sure.
Processing power increased.
Yeah.
Displays got better.
Uh-huh.
Sensors became more sophisticated. But you also had this cultural shift.
Okay.
People started to see the potential of these technologies beyond just gaming.
Oh, interesting.
And suddenly, everyone from tech giants to startups to investors was eager to get involved.
Yeah, it really does feel like this kind of explosion of possibilities.
It really did. It felt like the future was arriving.
Yeah.
Very exciting time.
But Professor Lee also points out that even with all this excitement,
Yes.
there are still some pretty significant challenges
Of course.
facing the field.
Right.
He calls these bottlenecks,
Bottlenecks, interesting.
and he mentions 4 key areas:
All right, I'm ready.
display resolution,
Okay.
latency
Yeah.
focus,
Okay.
and real virtual object registration.
Got it.
So can you kind of break those down a little bit for us?
Yeah, let's start with display resolution.
Okay.
Current VR headsets can still suffer from something called the screen door effect.
Screen door effect, what is that?
You can see the individual pixels,
Okay.
and that breaks the illusion of immersion.
Yeah.
So for a truly believable experience,
Yeah.
we need displays with much higher resolution.
That makes sense.
Yep.
What about latency?
Latency, that's the delay between your movement and the corresponding update in the virtual environment. Even a tiny delay can cause disorientation and nausea.
Oh, really?
Which is a major roadblock to widespread adoption.
So like you're moving your head.
Yeah, you move your head.
And it takes a second for the image to catch up.
Exactly, and your brain just gets confused.
Right.
That can make you feel sick.
That makes sense.
Yeah. Nobody wants that.
No, definitely not.
Not a good VR experience.
Okay, so we've got the resolution of the displays themselves. Yeah. We've got the lag between your movements and what you see.
Right.
What about focus?
Focus.
I know our eyes are constantly adjusting focus in the real world.
All the time.
How does that work in VR and AR?
That's a really tricky one because, you know, in the real world, our eyes dynamically adjust based on what we're looking at.
Right.
But many current VR AR systems have a fixed focal plane.
So your eyes can't really adjust.
Exactly. They're kind of locked into focusing at a specific distance. Oh, wow.
And this mismatch between what your eyes want to do and what they're forced to do can lead to eye strain and headaches.
So that's something that needs to be solved.
Big time, especially for long-term use.
Yeah. If you want to be in these worlds for extended periods of time.
Yeah. You don't want to come out with a headache.
Okay. So we've got the resolution. We've got the lag.
The lag.
And we've got the focus.
Focus.
What's that fourth challenge?
The fourth one is really specific to AR and MR.
Okay.
Real virtual object registration.
Okay.
It's about making sure those virtual objects are accurately aligned with the real world.
Oh, I see.
If they're even slightly off, it just destroys the illusion.
Right, like if you're trying to interact with something.
Yeah, imagine trying to grab a virtual cup of coffee.
Yeah.
And your hand just goes right through it.
Or it's like floating.
Or it's floating.
Yeah.
And it breaks the whole experience.
That makes sense.
Yeah.
So even though there's all this excitement.
Definitely.
All this potential.
There are still some pretty fundamental.
Absolutely.
Technical hurdles.
Yeah, we got work
that need to be overcome.
Lots of work. But we're getting there.
Yeah, it's this balancing act, right?
Yeah, it always.
Like pushing the boundaries of what's possible.
Yes.
But also making sure the experience is comfortable.
Yes.
Believable.
Right.
Ultimately enjoyable.
You want to come back for more.
Yeah, exactly. and that brings us to two concepts that Professor Lee really emphasizes in his research.
Okay, shoot.
Immersion and presence.
Yeah, those are big ones.
And I feel like those are terms that are often used interchangeably.
People mix them up all the time.
Yeah.
Yeah.
But he really makes this clear distinction between them.
He does, and it's an important one.
Can you kind of unpack those terms for us?
Sure. Immersion is essentially about the technology itself.
Okay.
You know how effectively the VR system engages your senses? Visuals, sound, even touch?
Right.
The more realistic and encompassing those sensory inputs are, the more immersive the experience is.
Makes sense.
Presence, on the other hand, is a psychological state.
Okay.
It's the feeling of actually being in the virtual environment.
Oh.
Of forgetting, at least for a moment,
that it's not real.
That it's not real.
Yeah. Okay. So you can have a highly immersive VR experience without necessarily feeling present.
Exactly.
Interesting.
You might be surrounded by, stunning visuals and sounds, but if something breaks the illusion...
Like a glitch.
Like a glitch in the graphics or a lag in the tracking.
Oh, yeah, that would pull you right out.
Poof, presence gone.
Wow.
And conversely, you could have a relatively simple VR experience with fairly basic graphics. But if it's designed in a way that really taps into your brain's sense of embodiment and agency, you can achieve a powerful sense of presence.
Interesting.
Yeah, Professor Lee actually uses this simple sensing perception model to illustrate this whole thing.
Okay.
How VR aims to kind of manipulate our brain's process of interpreting sensory input.
It's like VR is almost a form of illusionism.
It's like a carefully crafted performance designed to trick our senses into believing something that isn't actually there.
That's really interesting.
Yeah.
So the goal of VR isn't just about creating the most realistic visuals or sound. It's about using those elements.
It's about the feeling.
To evoke that sense of presence.
Exactly. It's about making you feel like you're really there.
Wow. And that's where I think things get really fascinating.
It does get really interesting.
So how do you actually achieve that?
The $1,000,000 question.
How do you make someone feel like they're really there?
Or
Professor Lee dives into a number of factors.
It does.
That contribute to presence.
Oh.
Things like vividness, the use of a virtual body, and interactivity.
I see.
So
let's break it down.
Vividness seems pretty intuitive.
Yeah.
The more realistic the experience,
right,
the more likely you are to feel present.
Makes sense.
But what about this virtual body?
The virtual body.
What is that all about?
It's really cool. Studies have shown that if you can see a representation of yourself in the virtual world, a virtual body that moves when you move, that responds to your actions, it dramatically increases your sense of presence.
Really?
Yeah, it just reinforces the connection between your physical self and the virtual environment.
So even just seeing like virtual hands.
Yeah, just seeing hands
that mimic your own movements
exactly.
can trick your brain into feeling more present.
Your brain is surprisingly easy to fool.
That's so wild.
It's amazing what our brains can do.
Yeah, and then there's interactivity.
Interactivity, crucial.
The more you can actually engage with the virtual environment,
right,
reach out,
right,
touch things,
manipulate objects.
Yeah, the more real it feels.
The more present you feel.
It makes sense that passive viewing wouldn't be enough.
No, you got to be a participant.
Right. To really feel present, you need to be able to participate.
Exactly.
Not just observe.
You got it.
And all of this comes back to the fundamentals of human perception.
It all starts with the brain.
Professor Lee spends quite a bit of time talking about how we perceive reality.
He does.
Focusing on vision and sound.
Makes sense.
Why is that so important?
Well, because VR is essentially trying to hack our perceptual systems.
Oh, why?
To create truly convincing virtual experiences, developers need to understand the nuances of how we see, how we hear, how we touch. You know, Professor Lee talks about things like our field of view, our auditory thresholds, our sensitivity to different frequencies.
Okay.
These are all factors that need to be taken into account.
So they really have to understand.
They have to.
The limits of human perception.
Absolutely.
To kind of create these illusions.
Exactly. It's like a magician understanding the limits of your attention.
Yeah.
They can create these amazing illusions.
That's so fascinating.
Yeah, the brain is a strange and wonderful thing.
Okay, so we talked about these basic concepts behind VR, AR, MR.
We've laid the groundwork.
We've talked about the challenges of creating these really believable experiences.
The bottlenecks.
Yeah, and the importance of understanding human perception.
Right, the human element.
So I think now I'm ready to kind of dive into
technical.
The nuts and bolts a little bit.
Yeah.
What are the key components of a VR system?
All right, well, at its core, a VR system needs three main things: a display sensors and a way to provide haptic feedback.
Okay.
So let's start with the display.
Yeah.
This is what you're looking at to see the virtual world.
Makes sense.
Probably the most immediately obvious component of any VR setup.
Yeah. And then we have sensors.
Sensors, yes.
Which I'm guessing are all about tracking your movements.
That's right.
In the real world and translating them.
Into the virtual world.
Into the virtual world.
Exactly.
Okay.
Professor Lee mentions things like accelerometers and gyroscopes, which are the same types of sensors you find in your smartphone.
Yeah.
They measure your head's movements, tilting, turning, nodding, and that data is used to update your perspective in the virtual environment in real time. So if you turn your head to the left, the virtual world shifts accordingly.
Just as it would in the real world.
Exactly. Your brain is none the wiser.
And I remember reading that MEMS technology.
MEMS.
Those micro-electromechanical systems.
Tiny little machines.
Yeah, are playing a big role in VR sensors.
They are everywhere.
What's so special about MEMS?
Well, MEMS are incredibly tiny and incredibly precise.
Okay.
They allow us to create these highly sensitive sensors that can detect even the slightest movements. And because they're so small, they can be integrated directly into the VR headset.
So it makes the whole system more compact.
Yeah, smaller, lighter, more comfortable.
That's really cool.
Yeah. It's pretty amazing what they can do with these tiny little devices.
Okay, and what about that third component?
Third component, haptic feedback.
Haptic feedback.
The sense of touch.
That's the part that makes your phone buzz, right?
Right.
So how does that work with VR?
Well, haptic feedback is all about simulating the sense of touch.
Okay.
It adds another dimension to the VR experience.
It's one thing to see a virtual object, but to actually feel it.
Oh, yeah.
That's a whole other level of immersion.
Right.
A simple vibration motor like the one in your phone can create basic haptic sensations.
Yeah.
But more advanced systems can provide much more nuanced feedback textures, pressure, even temperature.
Whoa, really?
Yeah. It's getting pretty sophisticated.
Can you give me an example?
Sure. Imagine you're in a VR game and you reach out to touch a virtual wall.
Okay.
An advanced haptic system could let you feel the roughness of the brick.
Okay.
The coolness of the stone. The solidity of the surface.
That's incredible.
Yeah, it's about engaging your sense of touch in a way that makes the virtual world feel tangible, real.
Like you could run your hand along the surface of a virtual object.
Exactly, and feel the texture.
And feel the texture.
Yeah, it's pretty mind-blowing.
It really is. I'm already thinking about how incredible that would be for gaming.
Oh yeah, gaming is a huge area for haptic feedback.
Like taking that taptic engine in my iPhone to a whole other level. Many levels.
It seems like such a small thing, that taptic engine, but...
It's a great example, though, of how haptic technology is already integrated into our daily lives.
It really is.
It might seem like a small thing, but it plays a big role in making our interactions with our devices more intuitive and engaging.
That's a really good point.
Yeah, it's those little details that make a big difference.
It really is, and it makes me excited to see where this haptic feedback goes from here.
Me too. The future of haptics is very exciting.
So we've covered the basic building blocks of a VR system.
The essentials.
The displays, the sensors, and the haptics.
The feeling.
But there's a huge range of VR experiences out there.
Oh yeah, a whole spectrum.
From these simple phone-based viewers to these incredibly complex setups.
Yeah.
Professor Lee talks about everything from Google Cardboard
the class.
to the sophisticated NVIDIA holodeck system.
Now we're talking.
What are your thoughts on Google Cardboard?
Google Cardboard, I love it.
So simple.
It's brilliant.
It's so effective.
You basically just slot your smartphone into this cardboard viewer and suddenly you're experiencing VR.
It seems almost too good to be true.
I know. It's amazing how something so simple can be so powerful.
Right.
The phone provides the display and the sensors. The cardboard just holds it all together.
Yeah.
The experience might not be as high fidelity as a dedicated VR headset.
Sure.
But it's a fantastic entry point into the world of VR. And, you know, the fact that Google sold over 500,000 cardboard viewers in its first week.
Oh, wow.
Speaks volumes about its appeal.
Yeah.
It really democratized VR.
It made it accessible.
Exactly. Anyone with a smartphone could experience it.
That's incredible.
It's a great little device.
It really is. But what about the other end of the spectrum?
Okay, let's go high end.
What about a system like the HTC Vive?
The HTC Vive now, that is a high-end VR system.
What makes it stand out?
Well, it offers a much more immersive and interactive experience than something like Google Cardboard. It has a wider field of view, higher resolution displays, more precise tracking. Yeah. It also comes with these hand controllers.
Oh, cool.
That let you reach out and interact with objects in the virtual world.
So you can really feel like you're there. You're present in that world.
But I imagine that comes at a cost.
It does. It's significantly more expensive than a cardboard viewer.
So it's this classic trade-off, right?
Always is.
Affordability, accessibility versus fidelity and immersion.
You got to choose your priorities.
Professor Lee also mentions the Microsoft HoloLens as an example of MR technology.
The HoloLens, oh yeah, that's a fascinating piece of tech.
What are your thoughts on that?
It's basically a self-contained, head-worn computer with an array of sensors, advanced optics, custom-designed chips.
Wow.
It projects holograms.
Or
what appear to be holograms. Onto your view of the real world.
So is it true holography?
Not in the strictest sense.
It's more accurate to think of it as a highly advanced optical see-through AR system.
Okay.
But the effect is incredibly impressive.
And it allows you to interact with virtual objects.
Yes, as if they were physically present.
Wow.
It's like magic.
It really does sound like we've only kind of scratched the surface.
We're just getting started.
Of what's possible with VR, AR, and MR.
Absolutely.
And I'm already eager to dive in even deeper.
Me too. There's so much more to explore.
We haven't even really talked about the Metaverse yet.
The Metaverse, oh yeah, that's a whole other rabbit hole.
Or the potential of these technologies to transform everything.
Everything's on the table.
From healthcare to education.
The possibilities are endless.
To the way we work.
The future is coming.
Yeah. But we'll save all of that.
For next time.
For later.
Stay tuned. Welcome back to our deep dive.
Back into the world of VR, AR, MR, and the Metaverse.
We've already talked about the incredible potential of all of these technologies.
We have.
But now I think it'd be fun to kind of explore some really specific applications, especially in fields like healthcare.
That's what I'm really excited about.
Yeah, Professor Lee highlights the use of AR in surgery.
Oh, wow.
Using the Da Vinci surgical system as a prime example.
The Da Vinci system?
Yeah, have you heard of that?
I have.
It's remarkable.
It is.
It allows surgeons to perform these minimally invasive procedures with incredible precision.
So how does it actually work?
Well, imagine a surgeon sitting at a console, controlling these robotic arms, while viewing the surgical field through a high-definition 3D camera.
Wow.
What's really fascinating is that AR overlays can provide the surgeon with real-time information.
Oh, wow.
During the procedure.
So it's like X-ray vision?
It's like X-ray vision, but for surgery.
Yeah.
This real-time information could include the location of critical structures, the path of instruments, that sort of thing.
So they could see things.
They can see things that they wouldn't normally be able to see.
That's incredible.
And this level of precision allows surgeons to operate with greater accuracy and control,
leading to
ultimately better outcomes for patients.
Better outcomes.
That's the goal.
It seems like AR can play a role in more than just enhancing the surgeon's vision.
Oh, absolutely.
In what way?
Well, AR can also be used for training and skill development.
Oh, that's cool.
Yeah, so aspiring surgeons can practice procedures in a virtual environment.
So they can hone their skills.
Exactly.
Before
operating on a real person.
Wow.
It allows them to build confidence in a safe and controlled setting.
So it's like a flight simulator.
It's like a flight simulator, but for surgery.
That's a really good analogy.
And then they can step into that real operating room with, more experience under their belt.
That's incredible.
It's really remarkable technology.
And AR can also be used during surgery.
It can.
To guide less experienced surgeons.
Yeah, providing them with step-by-step instructions and real-time feedback.
Wow, so someone more experienced could be
guiding them.
Guiding them?
Yeah, virtually.
That's incredible.
It's like having a mentor right there with you.
It's like having a co-pilot.
Exactly.
Yeah.
It's amazing to think how these technologies can not only improve the precision of surgery,
right,
but also make it safer.
Safer.
And more accessible.
Wow.
Yeah. It's a really exciting time for healthcare.
It really is. It seems like we're just scratching the surface.
We're just getting started.
Of what's possible with VR and AR in healthcare.
Absolutely.
So speaking of expanding potential.
Yeah, let's talk about...
Let's shift gears.
The Metaverse.
The Metaverse.
You mentioned before the break that Professor Lee talked about the IE 2888 standard.
Yes.
And its connection to building the Metaverse.
I remember that.
Yeah, it's
a little technical.
It's a bit technical.
Can you break it down for me a little?
I'll do my best. So the IE 2888 standard is all about creating a bridge between the virtual and physical worlds.
Okay.
Enabling a seamless flow of information between them.
Okay, so practically. Can you give me an example?
Sure. Imagine a digital twin of a physical object, like a factory.
A digital twin of a factory?
Yeah, it's a virtual representation of the real factory.
Okay.
Complete with all of its systems, processes, and data.
So it's like a virtual model.
It's like a virtual model.
That mirrors everything happening in the real world.
Exactly. And the IE 2888 standard provides a framework for connecting these two worlds.
So data from the physical factory
can be fed into the digital twin.
Okay.
And vice versa.
Wow.
So you could monitor the performance of the real factory in real time. Make changes to the digital twin.
And then see how those changes
would impact the physical factory all within a virtual environment.
That's incredible.
It's about creating this closed loop between the virtual and the physical.
So it's not just
a one-way street.
It's like a conversation.
Just a conversation between the real and the virtual.
That's a really good way to put it.
And this concept of a digital twin is central to the Metaverse.
Yeah, where the line between the real and virtual becomes increasingly blurred. It sounds very sci-fi.
It is.
Professor Lee mentions that companies like BMW are already using this technology.
They are. BMW is using digital twins for factory design and optimization.
So this is happening now.
It's happening now.
It's not just some future fantasy.
The future is here.
The IE 2888 standard has applications in a lot of other industries too, right?
Oh, yeah. Tons of manufacturing, energy transportation.
So it's not just about these cool VR experiences.
It's not just about the flash.
It's about
solving real problems.
Using these tools.
Yeah, making our systems more efficient and sustainable.
I love that.
It's about making a real difference.
Yeah, it's about using technology to actually have an impact.
A positive impact.
So as we're talking about all these possibilities, I can't help but wonder, where is this all headed?
The big question.
What does the future hold for VR, AR?
In the Metaverse.
Yeah.
That's the million-dollar question.
It's
hard to predict the future.
It feels like every day.
I know.
There's a new breakthrough.
A new headline.
What are some of the trends that you're seeing right now?
Well, one major trend is the push for even greater immersion.
Okay.
And realism.
So even more realistic.
We're talking Advancements in display technology, haptic feedback, even scent simulation.
Some simulation.
Yeah.
Yeah.
The goal is to create experiences that are so convincing you can barely tell the difference between the virtual and the real.
So it makes you wonder how that's going to change our perception of reality.
It's a big question.
Yeah.
What is real anymore?
But along with this quest for realism, you said there was also a push for accessibility.
Yeah, making this technology more available to everyone.
Okay.
VR headsets are becoming more affordable. AR experiences are readily available on smartphones and tablets.
So that these technologies aren't just for...
They're not just for the tech elite anymore.
That's really good.
Yeah, it's becoming mainstream.
I like that a lot more people can benefit.
Exactly. Everyone should have the opportunity to experience these amazing technologies.
And as these technologies become more widespread, we're going to see even more applications emerge.
Absolutely. The possibilities are endless.
And then there's the Metaverse.
The Metaverse.
Which is still...
early days.
Early, but...
Yeah, but it's got so much potential.
What could that look like?
Well, imagine a world where you can seamlessly transition between the physical and the virtual.
Oh, yeah.
Where you can attend concerts, visit museums.
All without.
Even go shopping, all without leaving your home.
That sounds like science fiction.
It does, doesn't it?
But I guess so many things that were science fiction are now.
Are now reality.
Yeah.
The line is constantly shifting.
So this whole conversation has been really mind-blowing for me.
It's a lot to take in.
We went from the basic building blocks...
the fundamentals.
...of VR, AR, MR...
Yep.
...to the almost unimaginable potential of the metaverse.
It's a wild ride.
I'm feeling inspired, excited, and maybe a little overwhelmed.
That's understandable.
By all the possibilities.
There's a lot to process.
So I think we should move on
Okay.
to that final part of our deep dive.
Let's do it.
Where we explore
the hopes and concerns surrounding these technologies.
And what they might mean for our future.
The future is coming, whether we're ready or not.
Welcome back to our deep dive. It feels like we've covered so much ground already.
It really has, hasn't it?
From those cardboard viewers to haptic systems to digital twins.
We've been all over the map of VR, AR, MR, and the metaverse.
And it really does feel like we're just scratching the surface.
I think that's right.
These technologies are evolving so quickly.
It's amazing.
It's hard to imagine what the future's going to hold.
But that's part of what makes it so compelling, I think.
I think you're right. That sense of the unknown.
The possibilities are endless.
The sheer potential.
Absolutely.
And that's why I think conversations like this are so important.
I agree.
We need to explore these potential benefits. Think about the challenges.
The ethical considerations.
The ethical implications.
Oh, not just about the tech itself.
Right. It's about what it means to be human.
Exactly.
In a world where those lines between physical and virtual
are getting blurrier and blurrier.
Are becoming increasingly blurred.
Yeah.
So as we move forward into this uncharted territory, I think it's important to stay curious.
Engage.
And stay mindful of the impact.
Absolutely.
But before we wrap up, I'd love to hear your personal thoughts.
Sure.
What are your hopes and concerns about the future?
Well, my biggest hope is that these technologies will be used for good. That they'll be tools for solving problems, connecting people, and making the world a better place.
I like that a lot.
You know, that's what really excites me about this field.
What about your concerns? What are some of the things that worry you?
Well, I think it's important to be mindful of the potential downsides.
Yeah.
We need to be aware of the risks of things like addiction, social isolation, the erosion of privacy. And we need to work hard to make sure that these technologies are accessible to everyone.
Right. It's not just for...
Not just for the privileged few.
Yeah, it's got to be for everyone.
These are challenges we need to address head on.
That's really important.
Yeah, it's not all sunshine and roses.
So we have to approach these technologies
with a sense of caution.
With enthusiasm and caution.
Yeah, a balanced perspective is key.
Yeah, embracing those possibilities.
But mitigating the risks.
Right.
That's the path forward.
And now I want to turn the question to our listeners.
Yeah, what do you think?
As these technologies continue to evolve, what are your hopes and concerns?
Where do you see yourself fitting into all of this?
Yeah. We'd love to hear your thoughts.
Join the conversation.
Yeah, this is a conversation that belongs to all of us.
Absolutely. The future isn't predetermined.
Right.
It's something we create together.
So to everyone listening, thank you so much for joining us on this deep dive.
It's been a pleasure.
We hope you learned something new.
Gained a new perspective.
And maybe even sparked a new passion.
And if you're feeling inspired, we encourage you to explore, further ask questions, experiment.
Be a part of it.
Be a part of shaping this incredible future.
Yeah, because the future of VR, AR, MR, and the metaverse isn't just about the technology.
It's about us.
It's about how we use these tools
To connect,
to create,
heal,
to make the world a more vibrant and meaningful place.
I love that. So go out there, explore, and let's build the future together.
Absolutely.
Until next time, keep diving deep.